topic is genetic environmental influences on intelligence and personality. And Dr. Nagoshi received his PhD in human variability psychology from the University of Hawaii in 1984. You won't look old enough. He did a postdoctoral, he was 12 at the time, did a postdoctoral fellowship in behavioral genetics and alcohol pharmacology at the University of Colorado from 1984 to 87, worked as a researcher at the National Institute on Drug Abuse in Baltimore before coming to the Department of Psychology at ASU in 1989. He's an associate professor there teaching history of psychology, behavioral genetics, and statistics. And his talk is going to cover issues of behavioral genetic research and the increasing acceptance in our society of the idea that there are biologically determined bases of socially important behaviors. So this is going to be a very fascinating talk. Let's welcome Dr. Craig Nagoshi.
Okay. Yeah, I love technology. Okay, well, some of the title of the talk is a misnomer. The description at the end is most of what I'm interested in, and I have a number of goals, and basically one of the goals is basically to kind of keep this loose. This talk can get really weird, or it can be pretty kind of straightforward, ASU lecture. One goal is to basically give an overview of what behavior genetics is about. I think some understanding of the methodology and assumptions of behavior genetics will kind of give you a basis for being more or less skeptical about the findings from the field. But beyond that, it's pretty clear that behavioral genetic findings are changing our social policies and our views of human nature. And that's something that, again, if you want to run with, we can get pretty far afield on this topic. My favorite class actually is history psychology. And when I teach my history class, it is primarily about how we understand human nature. And in particular, whether science is in fact, and this is heresy here, but whether in fact science is in fact the most appropriate method for studying human nature. History psychology primarily is about the incorporation of science into the study of why we do what we do. And so, I'll start off with the kind of conventional stuff, and feel free to ask questions and take it wherever we take it. Okay, so when we talk about behavior genetics, again, the assumption is that somehow there are variations in the DNA that somehow code for patterns of behavior. And this is a controversial idea. So let's start off with where we should start off with, and often behavior geneticists don't start off with, but you have to start with Darwin. And Darwin's theory of evolution is, I think, one of the most beautiful theories ever put together, in that it's incredibly simple. One of the things that bothers me about when people talk about evolution is that most people, including people who call themselves scientists and evolutionary psychologists, really don't understand Darwin. They overcomplicate it, make assumptions that are not really there. But Darwin's theory is incredibly simple. It's just based on three principles. And basically, any system can evolve in a systematic way if you just employ those three principles. Principle one is individual differences. It's just that somehow in the system, there's some force that creates differences that are stable among the individuals within that system. So basically, whatever you're talking about are widgets or people, or insects, somehow they're different, and they're born that way. The second principle is so-called maintenance of variation, which is that somehow, if you survive long enough, you will self-replicate. You will make more copies of yourself. And again, whether you apply it to, say a computer virus or a human being, if that thing survives long enough, there'll be more of them. Second assumption. And the third assumption is natural selection. And natural selection simply means that every once in a while something comes along and kills off some proportion of those individuals. Now, note that when I say kills off, I'm not saying there's any kind of systematic reason for things to be killed. It just does. Somehow, a bunch of people, individuals, units, whatever, get killed off. And what happens in such a system is that only those units that are better at self-replicating have a greater chance of survival. That's it. And from that, presumably, we can understand the nature of complex systems. Now the thing is that a number of things are not in the theory that people often assume. And like one thing that's not in the theory is any idea of progress. Okay, this is something that is called social Darwinism, and most people who talk about Darwin are actually talking social Darwinism, which is not Darwinism. So social Darwinism is something that Spencer formalized at the time that Darwin was publishing his theory, but that basically it made so much sense. And one of the themes I can get into is the contrast between, again, this heresy here as well, a rationalistic worldview versus an empirical one. Okay, the empirical view is that truth comes from observation. You basically accumulate enough observations of things, they will form patterns because nature is patterned. And if you simply accumulate enough observations, you will inevitably know the truth. Okay, that's supposed to be the basis of science. The thing, though, is that most scientists are not entirely empiricists. Most scientists are a combination of empiricists and rationalists. And this, of course, one assumption of the society, and it's a good one. It's the assumption of our society, basic Western civilization. Now, rationalism is based on the idea that somehow there is a means of using the mind to impose logical structures onto reality. And, it's, most forms by Plato, and, take it from there. But rationalism assumes that the mind is in fact superior to empirical data. That empirical data by itself is random, whatever, and that doesn't, quote, make sense until you impose such a logical construct onto it. Why am I telling this in the context of Darwin? Well, social Darwinism is essentially the rationalist attempt to try to make sense of what Darwin is saying. And in doing so, it distorts Darwin. And it creates all kinds of misconceptions about the nature of, in this case, biological systems. And one of the things that annoys me is that there's a lot of debate about Darwin, and it's misinformed debate on both sides. They're basically arguing about things that Darwin actually doesn't propose, and that are not relevant to how biological systems actually evolve. An anecdote here. At some point in my ASU career, I did teach one of the big intro psych sections. 120-some students, big auditorium, teaching introductory psychology. And when I started lecturing about Darwin, 3 students literally stood up, walked out the door. And I can tell you some other war stories about how Darwin is controversial. Clearly, we can talk about the Arizona legislature, the Kansas school board, etc. But again, it's one of my pet peeves that on both sides of the debate, I think there's a lot of misunderstanding about Darwin. This is relevant what I'm going to try to get into here about behavior genetics. The essence of Darwinism is that, again, you don't need any kind of conscious control of the system, whether it's by human rationalism and or divine intervention. The system runs itself. It's self-organizing. And this is an idea that is profoundly challenging to our civilization. And one of the cutting-edge philosophical debates in the sciences today is about, in fact, whether our worldview is essentially wrong. And this worldview essentially comes from Descartes. And Descartes is quoted here. Cogito ergo sum is about rationalism, saying that the only thing I'm sure of is that I exist as a rational mind that perceives reality. Let me just think about this. Behavior genetics. Well, there's a point. I'll get to behavior genetics. But the point is that, again, our civilization is based on rationalism, and Darwin is saying you don't need it. The system will organize itself. And one way of metaphor for this is that rationalism is a top-down philosophy, saying that reality is essentially chaotic, random, etc., until something from above imposes structure. onto that reality. Darwin is saying that in biological systems anyway, reality is from the bottom up. The reason you don't need divine intervention is because just by these three simple principles, things will in fact put themselves together in an organized fashion. And one of the ways I in fact challenge my class is to think in terms of, look outside your window, look at nature. I have a class next happens to be facing onto a garden at the psych building, and a bunch of plants there, birds going around, insects climbing up the plants, etc. But there's also viruses and bacteria interacting with the plants, all kinds of interactions at all kinds of levels, ranging from very simple viruses up to mammals in that environment. It's a very complex system just outside the window. And the question is, even if there were an omnipotent, omniscient thing running the system, in a lot of ways, like, why bother? It's just a lot of things that have to run. And the irony is that, it is. Darwin himself was not an atheist, and it can be fairly argued that by the end of his life, he concluded that, basically, if there was a divine force that ran the universe, natural selection is not a bad way to run it. Basically, put a machine together that essentially could turn on, and it would, in fact, change in systematic ways, and, again, essentially be self-running. And, okay, so this is Darwin. And this, again, leads to behavior genetics. So the notion is that in order for a biological system to be self-running, there has to be a way that, one, you have to create individual differences. And so one of the misconceptions about behavior genetics is that somehow genes make us all alike. And we talk about, talking to Bruce here about determinants of behavior. Do families transmit, let's say, criminality, etc.? And the answer is, well, yes, they do. But it's not as simple as that. It's not like, again, with the exception of identical twins, even they're not entirely identical. Most of us, the vast majority of humans, do not share our genes with anybody else, and we certainly don't share the same combinations of genes with anybody else. And as such, we're actually more different than alike in important ways. And when I say that, there's no back of my head. And on the other hand, we're all alike in other important ways. And I'll talk about that in terms of findings from the Human Genome Project. I have to get to that. But again, there has to be a mechanism for individual differences. And it turns out that genes are, in fact, a way to do that. And the genes are simply pieces of deoxyribonucleic acid, DNA, and the genes, in fact, scramble themselves in all kinds of interesting ways to produce us, produce any kind of a biological organism. And so one of the things I want to emphasize is that behavior genetics is about individual differences. And this, in turn, is important. Because for Darwin to work, there has to be some way that individuals are different from birth, and they stay that way. If they survive long, they replicate those individual differences. The second part is the maintenance of variation part, that these genes, again, have to allow for this self-replication. There has to be some mechanism whereby individuals repeat themselves. Now, beyond that is natural selection. Again, natural selection doesn't have to be systematic either. It's just about something kills off a bunch of those units, and those units survive because they've got some variation that makes them somehow have a higher probability of replicating themselves. And that's it. Now, note that, again, another misconception of Darwin is that we talk about selection of traits. And we tend to have this idea like, the example you're taught in high school biology is the example of the cabbage moth in England. Yeah, cabbage moths were white, and then there was industrial pollution which made all the trees gray, and so the gray moths survived. And the notion is that we think that the trait that was a survival trait was just discoloration. Gray wings on gray trees made you less likely eaten by birds. And to a certain extent, that was true, although there's actually an article about how those studies were kind of suspect. But the fact is that, again, the birds are not picking gray color. They're picking butterflies that have, or may not have, gray color. May they have other traits that more or less increase the chance of survival. Why is this important? Well, if natural selection is about the whole organism, not the particular trait, but the whole organism, it means that whatever traits that organism is carrying gets replicated. And the more complex an organism you have, the more traits get passed on. Now, some of you turn out older, some of you are thinking, well, what do I know about Darwin? What my conception is survival of the fittest. Now, that's the term that we're all, and we tend to have some preconceived ideas, rationalism, about what is fitness. And so when we think of what would be a really fit human being, we think, oh yeah, smarter, stronger, faster, Superman! Okay, well, that's our idea of a fit human being. In Darwinian terms, it may not be. Again, all Darwin cares about is, do you reproduce yourself? Whatever way. If in our society, the Woody Allen types actually reproduce more, well, yeah, okay. They are reproductively fit. Live with it. That really is the situation. And again, as long as the organism reproduces itself, those genes get passed on. Okay, so this is Darwin. Now, in behavior genetics, we're simply asking a fairly simple-minded question. And the simple-minded question is, if you've got genetic variation, some difference in the DNA between individuals, does that correlate with some behavior? And again, we're looking at individual differences here. We assume that for important human traits, like intelligence, like personality, people differ. Somehow, from a very, very early age, some are more smart than others, some are more extroverted than others, etc. And we're going to take those differences and ask the question, well, can I predict those differences from differences in the DNA? Now, I think I just use one slide from there. Okay, these are various ways that we get at genetic effects on behavior, and any kind of trait actually. Basically, up until very recently, up until the development of restriction enzymes for the dissecting of the DNA strand, behavioral genetic studies were done on the phenotype, on the trait. Whatever you observed with personality intelligence, you want to correlate that in some ways with assumed genetic variation. And that's where we get to twin studies, family studies, adoption studies. The notion is that in these studies, we know that these relatives differ in their degree of genetic similarity. We know that from Mendelian genetics, Mendel's ideas about how genes get transmitted. Even though Mendel himself didn't know what the genes actually looked like, how they work chemically, etc., it seemed that the patterns that the actual traits got transmitted corresponded to a model whereby, in fact, each parent contributes somehow half the genes to the offspring. Somehow the genes get combined in some interesting ways. They don't necessarily get just blended together. They combine in this fashion of one particle from one parent, one particle from the other parent gets combined. Sometimes the particle from one parent overrides the expression of the particle from the other parent. But it's a very systematic way of transmitting genetic information, and it's fairly simple. Okay, go back to Darwin. And this theme I'm going to harp on is that nature is interesting in that, again, it operates by very simple principles, and yet it yields incredible complexity. And again, the contrast I'm harping on is that that's very different from our worldview. Our worldview is that the more complexity we start with, again, the more rational we are, the more we're going to make sense of things. The more that things will somehow work out for us, and we control it, etc. Well, again, getting back to these designs, everything up to pedigree studies is essentially about looking at genetic relatedness assumed from different kinds of family relationships and correlating that with differences in behavior. So in the classic twin study, identical twins are clones of each other. Again, there was a silly question when Dolly the sheep was cloned. What if we clone a human? Will they have the same soul? We know this question already. Identical twins are genetic clones of each other. And we know that, they don't share the same soul. They're very much different individuals, even though they may share some peculiar psychological similarities. They are separate souls, or at least in terms of self-awareness, separate identities, and all that good stuff. Looking at the souls as well in this talk. the fact is that, again, yeah, identical twins share all their genes. Fraternal twins are like, non-twins, well, alike, siblings, non-identical twin siblings. They share about half their genes on average. So that difference in genetic similarity, if you correlate that with differences in trait similarity, you assume that that's a genetic basis. And that's all the twin study is about. Now, again, in the 1970s, restriction enzymes were developed that allowed for chopping up the DNA strand. And once you do that, you can manipulate it. You can look for DNA variations, and again, these are kind of terms that you've been hearing about. Restriction fragment length polymorphisms, single nucleotide polymorphisms, molecular genetic techniques, of which I'm not an expert. But the logic is that now, with these molecular genetic techniques, we can actually look at variation in DNA across individuals. These genes are no longer hypothetical particles the way that Mendel described. They are, in fact, actual, just chemistry, just differences in this, this compound called deoxyribonucleic acid. And there are various ways of somehow measuring these differences and correlating them with behavior. Now, what you're getting now in the media is this notion that, yeah, we can do this. We can actually look for differences in the DNA, correlate that with any kind of human trait that humans differ on. And once we get that correlation, we've established genetic determinism. That somehow these gene differences predict and probably control these trait differences. When you get to behavioral traits, again, the same assumptions made. A behavioral trait is simply another trait. Okay, so that's what these studies are about. Now I'll turn off the slide and let it be. Okay, so that's what we do behavior genetics. Now, one of the things that I'm noticing, of course you're noticing, is that more and more so the media are touting this notion that we're in fact going to be nailing down how the genes control behavior. And that has all kinds of implications that some of you may be quite pleased about, some of you may be quite frightened about. One implication is, in fact, this biological determinism, which is, in fact, assumed in Darwinism. If a trait has fitness value, it must be transmitted biologically. And therefore, it's biologically determined. Therefore, there is no other factor that's going to be important for the fitness of the organism other than what gets biologically transmitted. Now, that, of course, brings up the question of determinism. Now, I come from psychology where, for most of the 20th century, we believe in this thing called behaviorism, which is about environmental determinism. We believe that somehow what you learn through reinforcement and punishment was the primary determinant of variations in behavior. Now, psychology is becoming much more biologized. We're much more concerned about the brain and neural structures and neural functioning as the basis for differences in behaviors. But biological determinism and environmental determinism are really not that different. They're still determinism. They're assuming that some physical factor produces the behavior. And what's missing from the equation is, of course, this thing called free will. And this is what scares people. And again, it should scare you guys as well, because rationalism assumes free will. Rationalism assumes that there is, in fact, this mind, and this is Descartes, separate from the physical world. And being separate from the physical world, it can, again, impose structures onto this otherwise random, physical reality. And so again, in our society, oddly enough, you guys and the religious believers are in some ways on the same side in opposing Darwinism, in opposing biological determinism, because both sides. Darwinism basically is saying there's no free will. Your destiny is determined by these biological factors. We can admit that the environment can modify the biology, but it's still determinism. And that's where a lot of the debate comes from. That's where, there's a story about actually where the controversy about Darwin comes from, and the short version of the story is that, ironically, the reason that Christianity doesn't believe in Darwinism is due to Aristotle, who believed in, of course, the Greek gods. But that's not a story. If you're interested, I'll talk about it later. But the fact is that Darwinism and this biological determinism idea is threatening to a lot of people. and something that, when we talk about Darwin, people get kind of upset. It's like, does that mean that criminals can get, exonerated because someone's like a bad genes? Well, yeah, that's pretty much what it means, at least if you accept determinism, whether it's environmental determinism or biological determinism. And let's put that thought out there. Again, I want to talk about that as well. It's a good time to stop, actually. So at this point, I've thrown out a bunch of ideas. Any questions, thoughts, challenges? Yeah, sorry.
If father has schizophrenia, does that mean that the son liable to have the schizophrenia too?
Okay, yeah, good question. This is the belief that
Personal question.
schizophrenia is the psychiatric disorder that has
What kind of disorder did you say?
psychiatric disorder.
Yeah.
Yeah, it's the one that has the evidence for genetic causation. One figure is that if you're an identical twin and your co-twin has schizophrenia, your odds of being schizophrenic are anywhere from 6 to 8%, which is not complete determinism, but it's pretty darn close. Now, the thing though is that, again, family members that are not identical twins only share about half their genes, and furthermore, the process of genetic transmission is one where the genes get scrambled. It's not that, your mother transmits half the genes, your father transmits half the genes, just can put together. They also get put together different combinations. And
How likely is the kid to have schizophrenia?
the concordance rate for siblings and for parents and offspring is somewhere around 30 or 40%. It's far from guaranteed that if you have a schizophrenic first degree relative that you're going to be schizophrenic as well. And furthermore, it's not clear that's entirely genetic. This goes back to what I was saying about Darwin. One of the beliefs we have about genetics is that basically you've got a bad blueprint, and that bad blueprint makes bad behavior. The genes actually don't work that way. The genes code for protein synthesis. They code for differences in various physiological structures. When you get to behavior, it's quite problematic. The question is, what physiological differences somehow lead to behavioral differences? Now, the assumption is that it's out of the brain. That somehow the differences in neurotransmitter functioning, neuroanatomy, etc., that once those differences are in place as a result of genetic coding, that they will in turn produce differences in some kind of behavioral function. So in the case of schizophrenia, there are right now about 2 or 3 quote candidate genes. Genes, a single difference on a part of the DNA strand on some chromosome that are correlated with the occurrence of schizophrenia in some pedigree. And if they do nail down a gene for schizophrenia, it still begs the question, well, what does it code for? The likely candidates are that it codes for some kind of disruption in the normal development of the neural layers in the brain. Oddly enough, it appears that this dysfunction may not in fact be specific to schizophrenia. There may in fact be other psychiatric disorders like bipolar disorder, maybe major depression, that may in fact also result from this same gene somehow messing up neural development. One thing that's very complicated. In fact, this is a good segue into another part of this talk that I forgot about, the Human Genome Project. One of the most amazing things to come out of the Human Genome Project is not the fact that we're mapping all this DNA, but that the number of genes that we carry has dropped. When I started teaching behavior genetics, 14 years ago, I told my class that it's estimated that the human genome carries about 100 to 140,000 genes. A lot of genetic variation to track. Now the Human Genome Project is saying that, no, it's more like around 30 to 33,000. So why do we care? Well, why we care is that we share, again, the old number is 98.5% of our genes with chimpanzees. A new number based on a recent study is more like around 97% or 96.5, something like that. Well, it's still, the vast majority of our genes are shared with chimpanzees, which means by definition, there's no variability. That on those traits, whether behavioral or physiological, those traits are the the same for all human beings. But again, they define us as mammals, chordata, whatever, and things with backbones, things with central nervous system. I just heard a talk by the late Stephen Jay Gould years ago, where he talks about the fact that in Burgess Shale there are a number of lines of creatures. They're fairly simple creatures, man. And all those lines of creatures, most got wiped out by the extinction that followed. I guess that was the Cambrian period, extinction before the Cambrian period. And he pointed out there's one creature in the middle of Burgess Shale called Pikaia. Pikaia was, as far as we can tell, the first evidence for a chordata, an animal having a central nervous system cord. One point I was making is that it's pretty much dumb luck that this creature somehow survived the extinction and led to us. The point is that we share a lot of genes based upon this long, again, self-organizing process. Life has been on this planet for at least 3 billion years. It's a long time. And one of the arguments I make against somebody who says, well, how can you have such amazing things like the human eye just by a chance process? Well, again, nature had a long time to work on it. One of the misconceptions about Darwinism, evolution, and eugenics, actually non-naturally selecting for desired traits, is that we think it's easy. It's not. Again, nature took a long time to put together even multicellular life. And for humans to think that we can go in and within the space of, let's say, 100 years, somehow engineer a more perfect race, it's nonsense. So it's a lot more complicated than that. It takes a lot more time. Anyway, getting back to the issue of variability, if we share already at least, let's say, 97% of our genes with chimpanzees, then all the remaining 3%, I'll get 30,000 genes, 3% of those is about 900 genes. Take 900 genes and think, well, some of those genes just differentiate us from chimpanzees. So let's say conservative, half those genes are just about differentiating us from chimpanzees. So that means that these are genes that make us human and different from chimpanzees. They're also not going to differ. We don't differ from each other based upon, let's say, about 450 genes. That just leaves about 400 some genes that actually make us different from each other. And if you're thinking about behavioral traits like schizophrenia, intelligence, personality, it's not a lot of genes. Which begs the question, how can you get so much individual difference on the things that we care about, like personality, intelligence, schizophrenia, etc., based upon so few genes? And that gets back to what I was saying about schizophrenia and so-called developmental differences. That it appears that, again, the genes are not blueprints so much as starting points. Once you get that small difference, the genes that interact with other genes and with the environment in, quote, nonlinear ways. And nonlinear dynamics is, again, one of the hot topics in the philosophy of science, which goes back, oddly enough, to Darwin. Again, the notion is that it's not that there's some rational plan that organizes the universe, that instead the universe can self-organize is based upon some fairly simple operating principles. And it looks like human development is the same way. That instead of schizophrenia being some bad gene that makes some bad chemical like bad dopamine, which it was in fact the theory of schizophrenia for decades, it appears that what's probably the case is that there's some small genetic variation that somehow disrupts the normal timing of neural development. That small disruption of timing interacts with other genes that affect the timing of development, and the environment that interacts with the timing of development, and it's that combination that somehow goes, quote, chaotic. And chaos theory is another one of those concepts that's been thrown around. Well, chaos theory is an interesting idea. It's that systems are determined. And this determinism business is very important, saying that there is no free will, there's no divine intervention, there's just physical stuff that happens. And chaotic systems can be determined by fairly simple forces. So let's think about all these chaotic systems. The weather. Right now, we're experiencing a pretty cold April. When I interviewed at ASU, 14 years ago, it was about 14 years ago, I flew in on about April 18, it was 105. And I've never been 105. I was like, man, this is hot. But here it is, it's April 6th, and it's cold. Well, again, the weather is a system that can turn chaotic fairly regularly. And during the monsoon season here, the weather people are about 50% accurate during the monsoon season. Well, why is that? The weather is fairly simple. It's just, the sun heating up the atmosphere and the land. That's it. All the forces are determined, and yet certain combinations of forces quickly turn the system chaotic. Well, you really can't predict what's going to happen. And what makes a system chaotic? The key word is interaction. That every part of the system affects every other part of the system. And again, this is again the contrast to rationalism. Rationalism assumes that one idea, one theory, one ideal, etc., can somehow make sense of everything. The opposite view of self-organized system is that there is no one idea. There's just simply all these units that affect each other, and once they affect each other, they in turn affect everything else. And you just keep iterating on these different dynamic relationships, and just by this simple process, the system will systematically change. But it's going to systematically change in a way that's not easily trackable by any kind of overriding rational principle. So this is back again. We have 450 genes. How can we make all the complexity and variability among humans? Well, the answer is this idea that maybe there are, in fact, all of these, quote, nonlinear interactions, all these dynamic ways in which the genetic variations interact with each other. Again, even with 450 genes that are different, those differences in combination very quickly lead to a whole bunch of different combinations. So in the case, let's say, intelligence, there may only be like about a dozen genes that are actually involved in differences in, say, performance on an IQ test. And yet, think about all the combinations you make with 12 genes. It's huge. I was telling people at the table that I'm a little actually tired because I was playing poker until 3 o'clock in the morning last night. And, well, you play poker, you have a good appreciation of luck about that. Odd combinations can occur. In fact, the first time I played poker, 3 years ago, my wife got me into it. I got wiped out by this guy next to me that made 3 straights in 4 hands. And it's like, again, somebody thinking, what are the odds of that? It's like the odds of that are incredibly small. And I bet against it. I said, no way in hell he made 3 straights. Got wiped out. It happened. And I've had runs like that myself. The point is that when we think about odd patterns of behavior, like schizophrenia, what we like to believe is that it just represents some, really odd gene. It might not. It might represent just a very few slightly odd genes that interact with slightly odd environments to produce a very odd trajectory. Yeah, question?
Well, that would explain why schizophrenia is still around, the genetics, because if everybody that had the genes went totally institutionalized, bonkers, they wouldn't reproduce. But because if you may have the genes, but have a very supportive, loving family and a non-stressful life, and function very well and reproduce.
That's correct. And the thing with schizophrenia is that it typically doesn't really kick in badly until young adulthood. And so that's probably enough time for reproduction to occur. But that's a good question. The molecular genetic findings on the psychiatric disorders are interesting in that they're finding a lot of candidate genes to be, quote, dominants. And indeed in genetics, a dominant gene is such that you just have one copy of it, you will manifest whatever's coded for by that gene. Now, why is that controversial, or it's that natural selection should take out a dominant much quicker than a recessive gene. And so the model that I grew up with is that bad genes for bad psychiatric traits should be on recessives. Why would they be on dominants? It suggests that, one, either natural selection hasn't gotten to these genes, and or they may actually have some degree of adaptive fitness value. And that goes back to my idea about nature selecting the organism rather than the trait. That if in combination with some other traits, let's say having a somewhat schizophrenic gene is useful, well, that's going to be selected for. And when I talk about a developmental trajectory for schizophrenia, I talk about bad things like bipolar disorder, like autism is associated with this trajectory, etc. But it may be that good things are also associated with it. Quote, creativity, imagination, kind of eccentricity, but something that may, for a social species, to have just a few oddball individuals with oddball ideas, that may be adaptive and may have in some ways been selected for, while more extreme manifestation may be selected against. Got a question back there?
Did I hear you say that you felt that science may not be the best way to study human behavior? And if you did say that, would you clarify the alternative?
Okay. Well, in psychology, the problem is that we're concerned about, quote, why people do what they do. And people assume that they've got this wonderful thing called consciousness and free will. You know, we're self-aware, as Descartes' cogito ergo sum, and with the self-awareness, we can, in fact, will choices onto the world. Now, that, by definition, cannot be studied by science, because science assumes a deterministic metaphysics, that what we observe is something that can be physically coded for. Once we physically code for it, we can then make predictions, because whatever physically happens will happen again. And when it happens again, the effects of that happening will happen again. So, and well, one thing you should know is that in psychology, we kind of got our heads in the sand about this, in that we don't like to talk about free will. We act like we have it, but we don't want to talk about it. And that's the issue, particularly for me as a psychologist, that if we've got this rationalistic thing called free will, we may need to, in fact, kind of use non-scientific methods to get at it. Well, that's one issue. Another issue is that the model of science that we've been operating on since the Renaissance is Descartes' model. And in fact, this is actually a scene from Crichton's novel, Jurassic Park, which is an interesting novel in terms of discussion of the philosophy of science. Crichton talks about how the existing Western view, again, it's a rationalistic view. Descartes was really sick in bed, looking at the ceiling and seeing a fly moving across the ceiling and realizing, hey, I've got one set of coordinates running along one axis between the wall and the ceiling. I've got another set of coordinates running along the other axis between the wall and the ceiling. What if I plotted the fly's movement on that grid? What if I then made a mathematical formula based upon the x-coordinate versus the y-coordinate? A simple idea, remember, analytic geometry and all that, but the thing is that is the model for science. The notion is that we got data out there. Data are essentially random. They're not going to make sense until we actually impose some kind of structure, and mathematics is the most logical structure onto that. Now, get more heresy here. This literally the same idea is that there was chaos and then there was the Word. God moved upon, etc. But one of the ironies is that, oddly enough, Christianity is a combination of two different threads, Judaism and Platonic philosophy. And this fundamental contradiction between these two threads has been this bugaboo for not only Christianity but Western society as well. We just can't reconcile the two things. And in a lot of ways, Western science is not all that different from Christian theology, the heretical comment, in that it's an attempt to impose basically a godlike worldview onto essential randomness. And what these Darwinian or evolutionary-based ideas of self-organizing systems are saying is that you don't need God. The system will run itself without divine intervention, and the attempt to impose these kinds of rigid mathematical structures to explain things is basically fraught with error and the possibility that you're going to be wrong. That the minute you take the snapshot of what is happening in the system at a particular moment, it changes on you. And the next moment it's going to be something entirely different.
I'd like to ask a follow-up. Is it not the case that there is no such thing as true chaos, true randomness, and true free will, and that all of those things only happen within certain parameters? In other words, when a person argues to you that the eye was an act of a random act, that is not actually possible, that the eye could only evolve within certain parameters, that not any act could happen, only acts within certain parameters?
That's correct. In fact, the eye is an interesting example in that I read an article that indicated that the eye may have only evolved once in the 3 billion years of life. I mean, it's such an unlikely physiological structure. And it appears that, at least based upon the DNA evidence, that all creatures with eyes are descended from one creature way back when that somehow developed a way to convert light energy into neural impulses.
So my final point would be that human behavior could be studied as a science because human behavior is not, because there's no such thing as true free will. That because we are physical beings, there are certain parameters and certain limitations to our behavior. Not any behavior is possible, only within a certain defined parameters.
That's correct.
Which are repeatable and can be studied as a science.
Well, some of it can, some of it may not. There's a controversial idea that, well, a controversial question that I yank my students' chains with. Most of my students are interactionists. Like most students from our all quote interactionists. You believe in this Cartesian idea that there's the mind, there's the body. The question that I ask is, okay, if this mind is in fact, quote, non-physical, why is it in fact obviously limited by our bodies? We cannot imagine everything. We cannot will things magically. I mean, our minds are clearly, as you say, somehow linked up intimately with our body functions. And again, this is one of those fundamental contradictions in our thinking that, how do you resolve that? Again, the biological and environmental determinists would like to say that, well, there is no free will. You know, it's just body stuff, and that we can study, quote, scientifically. Well, then, you know, the counter argument is, okay, well, if you're choosing to study it scientifically, you're manifesting free will. And if you're imposing, you know, theories to study the study, you're being conscious, rationalistic, etc. So how do you resolve that contradiction? And the irony is that Western civilization, again, that civilization which came out of you know, Greek and Roman civilization, and characterizes European, this society, etc., is in fact an aberration. Most people around the world don't believe in this rationalistic, interactionist worldview. They believe in this funny thing called animism. Animism is the assumption that consciousness is inherent in all living things, even in non-living things, but certainly living things. And that to the extent that humans are, quote, more conscious than other living things, well, it may be because we just happen to have a physical form that better manifests consciousness. Now, I mean, it's a peculiar idea, but it is actually relevant to this behavioral genetics talk. But one of the things that you know is that a lot of behavioral genetic research is based upon animal studies, besides other animals. Somehow a lab rat will tell you something about schizophrenia in humans. Well, that's kind of an odd idea, because it's like, if in fact you're talking about a behavioral trait, why would a lab rat manifest anything of the consciousness and or free will that's associated with, let's say, schizophrenia? Now, my primary research area is in alcohol and alcoholism. Again, there are lots of mouse models of alcoholism. In fact, there are mouse models of so-called self-administration. Well, it's like, okay, if you find physiological genetic bases for why a mouse chooses to drink alcohol, it doesn't choose to drink alcohol, it still begs the question, where does the choice come from? Can a lab rat or lab mouse make a choice to drink alcohol or not drink alcohol? If it can, then it's got conscious and free will. If it can, it's irrelevant to human nature. It's studying human nature.
Question here.
Yes.
No.
Yeah, Ken?
Yeah, if tit-for-tat behavior among individuals in social groups is a naturally evolved method of dealing with organisms within that group that either that violate, let's say, the norms of the group or whatever. Would that lead to or determine a natural state of acting as if there was free will, in that we're attributing actions to others that they can be held accountable for, even though there might not be free will?
Well, the question is, well, the thing is that when I talk about the experience of free will, it's not attributing to others, that's attributing to ourselves.
We use free will to hold people accountable.
Yeah, well, the accountability part, though, is in some ways a social construct. That can be argued that free will itself is a social construct. We just make it up for the convenience of our society.
But isn't there a natural social contract that evolves through tit-for-tat behavior?
Yeah, there is actually. There's good evidence that other species have reciprocal social systems, but it still doesn't get around the question of if we experience our reality as one in which we can imagine alternate realities and then make choices among those alternate realities, regardless of whether anyone else can do it. In fact, it can be further argued we can't actually prove that anyone else has free will. So Descartes' cogito ergo sum is simply the notion that the only thing I'm sure of is that I have free will. I can imagine stuff. So, I mean, your question is valid, that it certainly can be argued that the idea of holding people accountable based upon some ethical system that they are responsible for their actions, yeah, that may in fact be an illusion. That in effect we all are just robots, and that for some convenience sake we make that stipulation. But for our own minds, for our own thinking, I mean, how do you account for that experience?
Would evolution determine that we act as if we have free will?
I'm not sure evolution would. Evolution would just be concerned about whatever works to, again, further adaptive fitness. And as far as I can tell, again, this is again imposing a construct, free will gets in the way. There's a question in front of you, yeah.
You used the word soul several times. Would you give me your definition of the word soul?
Okay, well, Descartes again formalized a system where he basically rendered unto the physical world the body and rendered to God the mind. And in Descartes' view, mind and soul were synonymous. Basically, his argument is that the only way that we could think rationally was that some quote, supernatural force had to somehow stick this other thing onto the physical body. And in psychology, and this is the thing we teach intro psych, psychology comes psyche comes from breath or spirit. And so up until very recently, mind and soul are synonymous. Nowadays, in fact, my students, the religious ones, wrestle with actually trying to separate the mind from the soul. They're saying that, yeah, there's consciousness that's individual, that I call mind, and then there's consciousness that's somehow shared with God, that's the soul. That's the definition that I get from these students. Yeah.
With reference to the Darwinian theory, what is the current explanation, or the Darwin's explanation, of the origin of life on Earth?
Well, the explanation, the Darwinian one, is that it was in fact simply in this process where there were molecules floating around, some precursor of a ribonucleic acid, RNA, that somehow self-replicated. Once they could self-replicate, of course, natural selection would favor those molecules that were good at it. And over enough iterations of that, somehow you created molecules that were self-replicating, and just constantly iterating this, eventually those molecules became things we call life. Even viruses were the first quote life form. Viruses are just a strand of RNA trying to stick themselves into some other cell to replicate themselves.
What caused them to self-replicate?
Literally nothing caused them. This gets back to what Darwinism is about. Just because they self-replicate is sufficient reason for them to do it. And as long as they're successful at doing it, they will persist. There'll be more copies of them in the world.
Sounds to me like you have a very narrow view of science. When you talk about being deterministic, I think of science as being the search for the truth by whatever means. Turns out that scientific methods being very, very good. But I think you're forgetting that most scientific work is probabilistic. I think you've forgotten your teaching of statistics you mentioned earlier. It's only the very hard sciences that things are 100%, force equals mass times acceleration and so on. But in other fields, like your own field, psychology and genetics, The work of Galton, for example, was very, very probabilistic. It wasn't deterministic.
All right, again, probabilistic is deterministic. It's not saying that, this is saying the contrary. We believe, I might do one, okay. The belief is that somehow, if you've got a causal factor, it inevitably produces a result. That's not what I'm saying. I'm just saying that determinism is simply saying that there is a causal factor. There is some physical force that produces the effect. That is determinism. And my view of science is that it has to assume that. Now, when you say that science is just some systematic study of anything, this is something that I really kick my students' butts on, because there are lots of people in our society that want to call themselves scientists. Again, I'm from the Christian Science in here. It kind of grits my teeth when I hear the term Christian scientist. It's like, the reason is that if you're going to be a scientist, you got to believe in empiricism. You got to believe that ultimately, when push comes to shove, truth has to be based on some physical observation. If you can't believe that, if you believe that something overrides that, you're not a scientist. And to call yourself one is just, trying to use a term that has some honor in our society. So my view of science is based on, if you want to call yourself science, you got to be an empiricist, or at least a rationalist empiricist, where again you'll yield to empirical evidence. You cannot allow free will. Now, if you allow free will and say that that allows you to be a scientist, but probabilistic, no problem for me. In fact, like I said, playing poker, I know very well that things can happen in weird ways. And in psychology, except we act on this party line that we're probabilistic, while denying any issue about this whole free will thing, which is not probabilistic. It's about some systematic way that things can change independent of the physical system. Yeah?
But the free will itself can be probabilistic. You have a certain amount of free will and have a certain amount of non-free will.
That I agree with. The question, though, is why do we have it at all? If the world is simply physical in its metaphysical nature, there can be no free will. There can be no outside force that somewhat changes things in the physical world. Yeah.
So, how much of the human personality do you believe is defined by genetics or genes?
Well, personality, more so than intelligence, appears to be very much so this developmental process where a lot of genes are involved, they have small effects, but in combination with other genes and environments, you can get a trajectory that produces huge individual differences. Again, think about how infants you've known. Think about the small differences between a temperamentally good infant and a temperamentally bad infant. And think about how those small differences can be magnified or diminished by the interaction of the infant with the environment, plus the natural developmental course of other genes kicking in development. In fact, I just gave a lecture on this. Ray Cattell, famous behavior geneticist, did his twin study from personality, where he actually talked about a so-called negative gene-environment correlation. That some of the genes push in one direction, your environment pushes in the exact opposite direction, kind of puts you in the middle of some socially functioning, middle ground for personality. Well, if the genes in the environment already work in these kind of complex ways, it's quite possible that very small differences in either genes or environments can produce very large effects down the road. But in terms of kind of giving actual nature versus nurture percentage, I give you the party line, which is that twin studies suggest that anywhere from 30 to 50% of variation in personality dimensions like neuroticism and extroversion, etc., are genetically determined. I don't buy it. I think that they are, but they're determined in a much more complex way.
Yeah. Doesn't the idea of mind and free will kind of muddy the water a little bit? Isn't it much cleaner just to think of choice as being neuronal activity interacting with the environment?
Oh yeah, it makes life much easier. That's why I said, my psychological colleagues prefer not to think about it. But again, prefer not to think about it, maybe free will. I agree. When I tell my students, but they have to write about this stuff, is that it's much easier to be a complete physical determinist.
before a question about schizophrenia. The reason I asked that question, and I was wondering what you would say to my daughter, who's thinking of adopting an 8-year-old boy whose father was schizophrenic. And she's concerned about the fact that the father was a schizophrenic as far as adopting this boy. Now, what would you say to her if she asked you the same question? What is the likelihood that this boy that she wants to adopt will be affected by it?
Well, I'm going to answer it in two ways. One is that I would tell her in terms of probabilities that the odds that that child will manifest schizophrenia are maybe about 25%, for whatever reason. So again, you're not at horrendously bad odds, but not horrendously good odds either. And the reasons for that happening, it may not be obvious. It may be, when I talk about gene-environment interactions, it may be that a small difference in behavioral patterns caused by genetic differences may cause, let's say, a daughter to respond to this child in a way that either magnifies or diminishes those effects. The other part of the way I answer this question, though, is to go back to the Human Genome Project. We will, in the near future, we're talking about 5 years, basically map all the DNA variations on the human genome. At that point, we'll be able to correlate these variations with risk for psychiatric disorders. And these correlations will range anywhere from, let's say 10% of the variants accounted for, 10% prediction to, let's say, about maybe 60%. I doubt we're going to get better prediction than that. That then raises the issue of, well, what are we going to do with this information? Because literally, we have the technology now to easily genotype people. It's like the Gattaca, put a blood sample, bam, you got your genetic profile. And they can tell you your probability for, say, developing schizophrenia, major depression, whatever. It's never going to be 100%. But how much of a risk factor is worth being concerned about?
Can I make a comment on that? This is sort of a sidebar to what you're saying, but I was particularly interested in a case that they presented on 60 Minutes several years ago. There's an adoption agency in New York City. It's called the Louise Wise Agency, and the reason I know this is because it is the agency that, when I was an infant, I was adopted out through this agency. There was a case that was brought to the New York courts regarding an infant that was adopted out from this agency to a family, and the family raised this child as their own. It was a boy, and in his teen years he began manifesting schizophrenia, and there was absolutely no history of it in his adoptive family. There was no reason why this child should have, they didn't quite know what it was. He was just having terrible emotional, mental problems, all kinds of difficulties with everything that was involved, and he was diagnosed schizophrenic. He fought against his demons, and he took drugs, and he seemed to be able to get it under control. He eventually did die of some other cause, but the family went back to the adoption agency and said, where was the disclosure of this? They did a trace, they found who the biological mother was, and they discovered that she was schizophrenic, and they had never been informed of this when they adopted. And they sued and they won because of the non-disclosure. And they're right now in the process of doing some things to try to make this better for adoptive families in the future. And the laws are changing, and there must be full disclosure of any medical things. Therefore, any possibility of some sort of negative genetic disability that could be passed on to an adoptive child that a family is considering must be made known to the family. And I don't know that schizophrenia is definitely dominantly passed along or what, but I'm just curious to know. I mean, if it must be something that is easily transmitted, that they would be able to prove this case. I'm not sure there's a question in here, but I just there's definitely a correlation then in It had nothing to do with the environment or anything else.
Well, it might have had to do with the environment.
They wouldn't have won the case if it did.
Well, what they decide in courts and what they decide based on scientific debate are two different things. This is what I'm saying about, when I began this talk, there's a real issue of biological determinism that, whether we like it or not, we're going to have to wrestle with. In fact, I advise my students that if you want to get into a lucrative field, study biology and get a law degree, because there already is a huge need for lawyers with expertise in genetics and physiological determinants of behavior. But what I see is trend is that more and more so our society is accepting biological determinism. That we believe that, yeah, there are bad genes that change behavior. We have no problem with bad genes changing a medical condition, but more and more so we think that we can somehow, again, genotype people, and we can, for some kind of DNA variation, and then make predictions, and probabilistic ones, about whether or not they will have a psychiatric problem. And again, the question I raise is, what do we do about it? In the case of schizophrenia, it is not a guaranteed thing that you got a bad gene, you're schizophrenic. And as I said, the way that the genes apparently cause schizophrenia are a lot more general than we take for granted. That there are probably a whole range of other disorders that happen as well with the same set of bad genes. And this makes prediction much more difficult. So let's say we did in fact determine a gene that's correlated with schizophrenia. I don't think it's going to account for much of the variance. I think probably you're going to get about a 20% prediction just from that one gene. And how that leads to everything else is going to depend upon other factors. Yeah.
Right here. We have one back here.
Oh, back here first? Okay, sorry.
Yes, I like your definition of free will. To my mind, free will is a choice between alternatives. And just because you've got N alternatives that most people can't maybe think of, doesn't mean that it is not still a choice between limits, which gets back to Randy's point that, it's science, it's within certain parameters, even though there may be N parameters. So free choice, isn't it just choices or free will?
Yeah, the philosophical issue is, how do you do it? If your brain is just a determined physical organ, then the physical determinant is going to say that, okay, you had the illusion of a choice. You simply reached the point where a number of physical alternatives were available and you fell into one. Now, the experience of free will is that, no, it wasn't really worked. I could actually imagine different things. Like, I can imagine my hand going this way, or I can imagine my hand going this way. I chose one or the other. So again, how do you do that within a determined system? Which still gets, this issue of, if the system is limited, if your mind cannot imagine everything, then somehow the physical system does impose limits, or that in turn contradicts Cartesian dualism. Oh, sorry.
Yes, I had a son who was a paranoid schizophrenic, and he was also Klinefelter syndrome, if you know about that. He had an extra chromosome. And that was I just wanted to put that in there, because this is also just one of many variations of the genetic makeup. And so it's very interesting, and he was an identical twin. And I lost the one at 6 months, so we have no way of knowing if that child would have been like his brother. But it is a tremendously important thing for us to try to understand. Of course, like you say, what do you do about it now? But hopefully in time, with the genome thing, there could be some help for a person who is already predetermined to be a schizophrenic.
Well, there is, and that's actually the vision or the horror, depending on your view. As an anecdote I tell that some 14 years ago, I attended a meeting of the Research Society on Alcoholism, where the speaker was Fred Goodman, who was then head of the Alcohol, Drug Abuse, and Mental Health Administration, gave his vision for the future of alcoholism research. And at that point, the National Institute of Alcoholism had just begun funding the so-called collaborative study in the genetics of alcoholism, study of involving a number of university sites, a study of some 900 alcoholics and their families in a pedigree study to try to check, find genes for alcoholism. But Goodwin's vision was that we're going to be able to target children at genetic risk for alcoholism for pharmacological interventions before they take their first drink. I.e., we're going to take a blood sample, figure out you got a bad gene for alcoholism, and give them drugs to make sure they don't become alcoholic. Now, most people in the room are saying, yeah, that's cool stuff. I was like, and again, it sort of depends upon this worldview about how much do you value this funny thing called free will. Because if you believe that really it is just a physical system and that for the benefit of your society, you need to be fixed. If you're carrying a bad risk for bad behavior, then no problem. Yeah, Goodwin's vision makes perfect sense, that we should genotype people and fix them before they manifest bad behavior. If, however, this wonderful thing called free will that somehow allows you to make choices to avoid or change your physical determinants of your actions, well, then life's a little more tricky. Then imposing treatment is a violation of some ethical principles.
Okay, we have a question here, and then we'll take one more after that, and then that'll be it.
You were talking about the correlation between concepts like intelligence and personality and genetics, and I have a feeling those are fairly problematic and complex terms in psychology. I was wondering, what do you include in the term personality? Does it include things like gender, sexual orientation, alcoholism? What are your parameters for that word personality?
Well, it's, like most terms in psychology, these are all, quote, constructs. They're just things you make up to organize our observations about behavior patterns. Personality is defined in psychology as a stable individual difference in some organized pattern of behavior. And you're right, we can throw in alcoholism, we can throw in pretty much anything that represents a unique behavioral pattern. Follow up?
Okay. Anyone else? Any other questions? One last question over here. Hold on.
Do you have any direct evidence for free will?
Well, actually, no. It kind of depends on what you mean by direct evidence. And this gets back to, well, should we do science? One of the things that I argue in my class is about these so-called narrative approaches in psychology. Now, if you're a psychotherapist, you're particularly concerned about this idea that, well, some psychologists have bought into the deterministic framework. I think bad behavior is a result of bad environments for bad genes. Okay, so you've got no problems with the existing politically correct vision. But if you think that there is such a thing as free will, and the irony is that in talk therapy, you're actually trying to get people to make choices that will somehow change their thinking about their reality and then change their behavior. And yes, it's hard to get around that. So if in fact you believe that people can change their worldviews and their behavior, how do you get them to do that? And furthermore, how do you prove they're actually doing it? Well, think about the ways that you learn about human nature. Now, a scientist would say we learn about human nature by just observing things. We see how people behave, or people tell us things about why people behave, etc. Again, part of the creed of the society is that we're inspired by art. Well, what is the role of art in human societies? How does art work? And one of the things you didn't know about is I'm a musician. And so it's one of the things I do. And for a very long time, I lived kind of two lives. I was doing the science thing, academic thing. I was doing the music thing. And I thought the two were just totally unrelated. They had nothing to do with each other. And back in '94, the two worlds came crashing together. It's a long story, but and this goes back to my talk about animism, oddly enough. What if consciousness really is not separate from the physical world? What if you believe that life really is the result of some, quote, life force inherent in all living things that manifests more conscious and free will the more organized the physical stuff is? So in terms of how do you prove it? I would argue that a lot of our experience, a lot of our truths of the world are based on hearing stories. And art is essentially about sharing an experience. In order for the artist to communicate, they have to get the audience to basically, quote, suspend disbelief, basically let go of the boundary between the individual rational mind of the audience with that of the artist. Similarly, the audience, in order for art to work, has to do that as well. Art doesn't work if both sides are playing scientists, basically. I'm the object of this subject acting on me. That's not art. Art's like that. It's just commercial stuff. It's just commercial stuff. I'm kind of cynical about that. But a lot of our art is treated that way. It's just a commodity. And to that extent, we think it's bad art, or it's commercial art. It's just not art. Whereas when art moves us, when we read a novel that really gets to us, we've reached a state where we've, quote, by choice, let go of that boundary between our individual mind and this other mind, the mind of the artist. And my argument is that that's really the way we learn about free will and consciousness. That in this way of, quote, sharing experience, this is what Buber calls the I-thou relation. It's about souls. That a soul connection is about somehow merging your mental reality with the mental reality of another person. And it's a phenomenon that I think a lot of us take for granted. Some of us actually celebrate it. But if you're a scientist, you can be highly skeptical of it. It's still just observing behavior. It's still about just socially learning how people are thinking, speaking, responding. But it's not a connection. It's not anything, quote, supernatural. And I can grant that that's a legitimate worldview. But the counter view, though, is that for art to work, maybe it is something that is somehow about this kind of special connection. And that is, again, the way that we assure ourselves that not only do we have free will, but somebody else does.
I think that's a good place for us to stop. And thank you. I know you're all running out of questions. You've left us with a lot of other things. They're going to come up and mob you in a minute with questions, I'm sure. Before you go, though, we'd like you to have this little piece of reality called the Humanist Society of Greater Phoenix Mud as a thank you. And we hope sometime you'll come back and join us and visit with us and speak again, and also, come sit here and throw questions at our next speaker. We'll be here in 3 weeks on April 27th. For those of you that arrived late, we are not meeting in 2 weeks, we're meeting in 3 weeks. Also, we have copies of the Page of Reason over there with our complete list of speakers. For those of you that are on the internet, it's at our website, www.hsgp.org.
If you appreciate the Humanist Society of Greater Phoenix and would like to see more, then subscribe to our channel and check us out on Patreon. Links are in the description.